Hi guys, welcome to this set of videos. What we're going to do in this set of videos is we're going to continue this discussion that we've started about doing geometry involving circles. What we looked at in the previous set of videos was central angles and inscribed angles. These are angles that we find inside of circles. What we're going to take a look at here in this section, this set of notes in these videos, is we're going to take a look at inscribed polygons, in this case inscribed quadrilaterals. Remember, a quadrilateral is simply a four-sided figure. So here's the question that we're going to try and answer. We want to know, what can you conclude about the angles of a quadrilateral inscribed inside of a circle, right? That's what we want to know. Something about the measure of the angles of a quadrilateral that is drawn inside of a circle. I actually have a picture of one down here for you. You'll see when I slide up. Well, there's a few things that we need to talk about first. A couple of things you guys need to be able to do in order to answer that question about the angles of a quadrilateral. So the first thing we're going to do is we're going to get you to understand the relationship between the angles of those inscribed quadrilaterals. There are some relationships that exist. We'll talk about those relationships, and then of course, as is always the case, once you know a little bit of geometry, what's the relationship between the angles of the quadrilateral? You're going to use it to do some algebra. We'll have you solve for unknown angle measures for these inscribed quadrilaterals, right? Just has been the case throughout this entire course. We learn a little bit of geometry, then we use that geometry to set up an algebra problem. Okay, here we go. Like I said, what we're doing here in this section is we're talking about quadrilaterals, which is a polygon with four sides. It's a four-sided figure, but that four-sided figure is drawn inside of a circle. And really important, each of the vertices of the quadrilateral lies on the circle. All right, I can't have one of those vertices not be, well, you could, but then these theorems we're about to talk about wouldn't apply, right? So this theorem we're about to get here, the inscribed quadrilateral theorem, only works if the vertices of the quadrilateral is on the circle, right? Each of those vertices has to be on the circle. Now, what's the theorem? It's actually a really simple theorem, and it simply says this: opposite angles of the quadrilateral are supplementary. That means they sum to 180 degrees. Here's all that's saying. Really simple. The measure of angle A plus its opposite angle, the measure of angle C, right? A and C are opposite angles, and the theorem says they have to sum to 180 degrees. That means then that the opposite angles, D and B, also must sum to 180 degrees. That's it. That's all the theorem is saying. If you have an inscribed quadrilateral, an inscribed four-sided figure, opposite angles must sum to 180 degrees. They are supplementary. With that geometry, let's do a whole bunch of algebra. So here we go. I have an inscribed quadrilateral. This is a four-sided figure, and I've given you some information about a couple of the angles. Well, I need to find the ones that are opposite each other, and I know something about both of them. Please notice that I know something about angle P, and I know something about angle R. Since they're opposite angles, I know that they have to sum to 180 degrees. Why am I going to pick those two? Well, because Q and S are opposite angles, but I don't tell you anything about angle S. So you'd run into a roadblock. You kind of run into a dead end because you don't know anything about S. Since I know something about both P and R, that's what I'm going to use. The theorem says the measure of angle P plus the measure of angle R is equal to 180 degrees. That's the geometry. Let's do some algebra. What is the measure of angle P? It's 5y plus 3. What is the measure of angle R? 15y plus 17. That all has to be equal to 180 degrees. Guys, we're going to go ahead and combine like terms and then solve for y. So 5y plus 15y, 20y. 17 plus 3, 20. That's equal to 180 degrees. Guys, how do I get the y by itself? Absolutely. You will subtract the 20 to the other side first. 20y, sorry, not 2y, 20y is equal to 160 degrees. Divide both sides by 20, and we get y is equal to 8. Now that I know that y is equal to 8, we can go ahead and solve for each of those angles. Let's start with P. The measure of angle P is 5 times 8 plus 3. Go ahead and plug that into a calculator if you need to. Don't fat finger something and you should get 43 degrees. Let's find the measure of angle R. The measure of angle R is going to be 15 times 8 plus 17. Once again, it's a calculator problem. 15 times 8 plus 17. Don't fat finger something on your calculator. You get 137 degrees. We are on a roll. We got a couple more to find here. Let's find the measure of angle Q, since I tell you something about that. Q is y squared plus 53, which means the measure of angle Q is going to be an 8 squared plus 53. Again, you can use your calculator to do this, but it's not too terribly tricky. 8 squared is 64. 64 plus 53 is going to be 117 degrees. All right, now we come to the tricky one. Maybe, I don't think so. It's not that tricky. Here's what you know. You know angle Q and angle S must sum to 180 degrees. The measure of angle Q plus the measure of angle S is 180 degrees. But you already know the measure of angle Q, so plug it in. You solve for the measure of angle S. That means the measure of angle S has to be equal to 180. I would have to subtract the measure of angle Q to the other side, so minus 117 degrees. And the measure of angle S is 63 degrees. Alright guys, that's the way these problems are going to go, just simply using that quadrilateral, the inscribed quadrilateral theorem, knowing that opposite angles of an inscribed quadrilateral are supplementary, we can solve a number of problems. Head on over to the next page of the notes. I'll take a look at a couple more of these with you, and I'll meet you guys there.